Hey, good morning, everyone. Good evening, everyone. Thank you for joining this session today. So, my name is Ritesh. I'll be your host for today. And today we are here to talk about containers, right? And how you can start leveraging containers and how can you start thinking about containers, right? So today's agenda, if you look at, so today what we plan to cover, we plan to go into a little deep to understand what containers are all about, right? We're going to talk a little bit about what containers are, what are the use cases you should look at using containers, and where what challenges does container solve, right? So we will go and understand that piece so that you understand where does it fit in the whole ecosystem and which are the use cases that containers make sense, right? Then we will understand how you can run containers on AWS, right? So AWS is Amazon Web Services. So that's one of the predominant cloud platforms today, right? So what are the different services that AWS gives to run your containers? We will go into a brief understanding of different services that AWS have to run your containers, and we will see which one has what advantage over the other, and then do that, right? Then we will look at what are the advantages of running containers on AWS, right? So why should you run containers on AWS versus running on data center or running on many other platform? What advantages that AWS gives you, right? And then last but not the least, we'll also look at some of the use cases, right? So we're going to focus on use cases on containers and see where you can pitch your containers around, right? Where you can build your containers. Now let's come to our topic, right? Topic for today is containers, right? So we want to understand what containers are, right? So if you look at broadly, right, what containers are basically a unit of software which packages your application code and along with all your dependencies so that you can run anywhere, right? So what do I mean by this? So basically, what you do, right? So when you start writing your applications, right? So let's say you write your application in Java, right? You build your application, right? So you have written your Java. When you write your Java class files, right? Your Java files, then you compile, and then you have dependencies, right? You have your jar files, multiple dependencies that you would have, right? You bundle all the dependencies with your application, and you bundle this into a either a jar or a var or a EAR, right? This is how you bundle it. And then what do? You run this on a application server. So think of it like you run on a Tomcat, right? And this Tomcat is running on a OS, right? So let's say you are running on RHEL. Now what happens? Now tomorrow, if you take this, right, the same war file, right, and you run onto a different OS, right, might be the same, right, the same RHEL but on a different machine, right, RHEL, chances are there that you might miss some of the dependencies, right? So if you're running the same application, the application has multiple dependencies. If you miss any of the dependencies which your application has, then your application will not work. It becomes very tedious and very difficult to troubleshoot and figure out what is breaking, why it is breaking, and things like that, right? So that's where because you have your application only bundled, there are many dependencies that are outside your application. So what are the examples? The example can be your monitoring, right? The example can be your logging, right? You're doing logging on your application. The example can be tracing, right? So these are outside your applications, but these are dependencies that your application would go through, right? Now if you miss any of them, you would not be able to do it. Now you as a developer or as an administrator have to troubleshoot and make sure that things are there, right? So what happens? So you would commonly see developers coming and telling, hey, this application works perfectly in my laptop, right? But when I take it to my dev environment, when I put it on a dev server, it's not working. Something is breaking, right? Now when I and then you fix this. Now you've done your testing. Then when you take it to your stage environment, again something is breaking, right? Why? Because it might be multiple different reasons. The reasons might be the OS version you're running. The OS version here is different, right? The dependencies that you have is different. On the laptop, you were using different tracing tool, right? or logging tool. On your corporate environment, on your dev environment, you need a different tracing tool as per your corporate policy. On your production, you have a completely different tool that you use, right? So these all challenges would come into picture because all these things are outside your application code, right? These are dependencies that are outside your application code, right? And these are real problems that you'll encounter when you start building applications and shipping the applications in production in a traditional way. What I mean by traditional way means the way that we discussed, where you have your OS and then you have your application server and then you run your code on the top of it, right? So this is your app server. So like we talked about Tomcat, right? And this is your RHEL and this is your app. All right. So your dependencies are outside your app, and then you have those problems coming in, and you have to troubleshoot it. Now this doesn't become portable, right? This is a lot of dependencies that you build in, right? It can be like if you're building a Java application, it can be a JDK, right? Your JDK in your development environment it was 1.7, but in your production it is 1.6, right? So you would have challenges with that. That's where your application and your things come into picture. Now, what does containers do? So what do you do? So basically containers, think of it like a package. So whatever is your application code and your dependencies, right? So like your logging, your monitoring, and whatnot, you package everything together and make a container, right? Now what you do, you run this container on the OS directly, right? You don't have to worry running this differently. Now this package, if it runs on your laptop, it will run everywhere else because the underline is the container who runs it, right? So that's the main thing where containers come into picture, right? So that's the main reason why people started adopting containers, right? So it becomes more easy, more portable, and you can run things much faster, right? So that's where we talked about containers are executable unit of software which application code is packaged along with libraries and dependencies so that it can run anywhere, right? So think of it, the analogy is, think of your shipping containers, right? You would have seen your shipping containers, right? They are isolated individual components. Similarly, these are containers in technology. The analogy you can think of it, whenever you're thinking of containers, think of the ship and the container that you have, right? So get that analogy, you'll understand it better. That's about containers, right? Now moving on. So this is what we discussed, right? So typically what happens when you talk about your infrastructure, you have your hypervisor. This is your virtualization software like your VMware or Hyper-V, right? Then you have multiple OSs, right? You have your guest OS like your Windows. You can have another was Linux. You can have Ubuntu, right? And you have your binaries running, right? Now what happens? You have your applications running, right? Now each OS would have their dependencies, right? And then you have your OS's dependencies mapped. Now this is how you typically run on a virtual machine world, right? Before containers, right? The virtual machine world. Now when you go into containers, there's a container runtime, right? This is where your dockers of the world come into picture. So dockers of the world is basically a container runtime. Is the responsibility of the container runtime to run the container, right? So it's an abstraction on the top of your host OS, right? So your host OS can be Linux and you can run multiple containers on the top of it, right? So there are multiple reasons. So if you look at the benefits that you get, so if you look at now when you're running your guest OS, right? So what happens? The guest OS also takes a lot of disk and memory, right? Because the OS itself would take X amount of GB of memory disk, X amount of GB of memory, right? And then to the guest OS to run. And on the top of it, you run your application. Now, in the other side, on the container, you're directly running on the container runtime. So you save a lot of your bandwidth in terms of CPU and memory for running your guest OS, right? So that's a benefit that you get. So your containers are much more smaller, much more portable, and run much more faster because you're just saving a lot of for time and complexity for running your OSs. Now, if you see this of the virtual machine, you're running three, what do you say? Uh, if you see, you're running three different guest OSs, right? So each OS would take time, right? So this is overhead. Now here you have removed all that. You don't have guest OS, right? Now, second, from a cost perspective, right? You are running this hypervisor. So the hypervisor has a cost, right? Because if you're running VMware, there's a VMware cost. Here you can run containers on directly on a bare metal, right? On a server directly you can run your container. It again saves your cost, right? And also portability. So we understand what containers are, right? Now the second thing that comes is how do you run on AWS, right? So I want to run containers in cloud. So what are the options do I have, right? So when we go into AWS, there are multiple options that you have. So now the biggest concept that comes is container management tools, right? So because now you have so many containers that you have to run, so you need orchestration tool who will manage this. So think of it now, think of it on EC2 you have basically servers, right? Sorry, on AWS you have servers which is called as EC2, right? Now you can have an application which runs across multiple servers, right? Because it's a very huge, so think of it, you're running a Flipkart, right? So just an example, right? So if you're running a Flipkart, so think of it, how many containers would they be running, right? Or how many applications they were running. Each application would have multiple containers, right? Which will spin across multiple hosts. One host would not need. Now you need an orchestration platform which will help you to manage this across scale, right? You might have one data center, you might have 10 data centers, right? And you want to run across multiple data centers, multiple environment, and you want to orchestrate all this. And that's where the importance of a container management tool comes into picture, right? So the first thing is you have a container registry. So what is container registry? As the name says, registry. This is where you register the container, right? So think of it like a telephone directory, right? So you go and register your container because anyone can discover it. So if I want to find out, if someone wants to find out Ritesh's mobile number, what you can do, you can go and search on the directory and find out that what is my mobile number, right? Similarly, this is a registry where you register your containers so that anyone can discover it. So that's called as registry, and AWS service is called as ECR, Elastic Container Registry. So that's an AWS service where you can register your containers. Now, after you've registered, you want to orchestrate, right? As I said, you want to orchestrate. So there are multiple services. AWS gives you something called as ECS and EKS. These are two different services which helps you to orchestrate across multiple containers that you're running in the environment, right? So you can have containers for one application, containers for multiple application. One application can have multiple containers. So if it's a 3-tier web application, you have a web layer and an app layer and a database layer and a cache layer, your search layer. All that has to be orchestrated as one application, right? So that's where orchestration comes into picture. And we have multiple tools like ECS and EKS. These are two services in AWS where you can build your orchestration layer. Now from a core, right, compute, so you can run these orchestration on an EC2. EC2 is your virtual machine, or Fargate, right? These are computing options. These are where you get your hardware, the CPU memory disk to run your containers, right? Now let's look at one by one each of them. So what is ECS? ECS is Elastic Container Service, right? What is Elastic Container Service? This is a container management service from AWS. This is AWS proprietary service, right? If you want to run containers at scale, so ECS can be one solution that you can look at, who can help you to run containers at scale. You can manage multiple containers, you can stop, you can manage containers on a cluster, right? So ECS is AWS proprietary service, right? So if you want to say, hey AWS, I want to use ECS and I want to run my containers, you can do that. So that's a service which will help you to run your containers on ECS. So ECS will be your container management service. So it will be responsible to orchestrate, to manage, to make sure that, so if you say, hey, my web layer should have 5 instances of my web container, right? So if one container dies, it's the responsibility of ECS to make sure that you have one more container coming up and you have 5 servers now running, because you have said I want 5, right? So based on your definition, it will make sure that whatever you have requested, you get that. So it will make sure that you get whatever you have requested. So that, how do you request? You have task definition. So task definition is a component or a definition that you put where you say what you want, how your container defines, right? So basically what happens, you have your task definition, and in the task definition you say that, hey, I want to run these tasks, and the ECS will schedule this task on the ECS container cluster, and it will run it, right? Let me go back to my drawing board to just make it a little more clear what we are talking here. So when we use ECS, right? So AWS ECS. So this is your container registry, right? So sorry, container orchestration tool, right? So what happens now? I have an application, say A1, and in this application, this is a three-tier application, right? So three-tier. So what would a three-tier application mean? It will have a web layer, it would have an app layer, and it would have a database, right? Now I have three different containers which does this. So I have a web container, I have an app container, and I have a DB container, right? So I'll say web1, app1, DB1. Right? These are three containers that I want to run, right? Now what else? I would say, hey, I need five of them. I need three of them. I need two of them. That's my definition. I need these many. So what I want five web servers running, web containers running. I want three of these running, and I have two on my databases running. Why? Because I know I get so much request. I want to build this. Now, who will run this? So you will define this. This is your task definition. This is where you define your task. You say, hey, I want to run this, right? This is my task definition. And then when you give this task definition to ECS, not EC2, sorry, my mistake, ECS, right? ECS will run this. Run on what? These are the containers that it will spin, but run on what? Run on EC2 servers, right? So EC2 servers. So EC2 servers are the virtual machines, right? So think of it like a virtual machine. They will run on the virtual machine and they will make sure. So if one goes down, something happened and one container died, right? So what will happen? ECS will say, okay, you have defined five, now it is four, I will spin one more. That's my responsibility, right? So it will ensure whatever is your task definition, it runs this. Now, second thing, you have seen W1. What is W1, right? So this is a container image, right? You create an image. Now, where is this image? So it will again go to your registry, right? You will have your container registry. And as we talked, in your registry, you have said W1 equal to this image. W2, sorry, A1 equal to this image, and db1 equal to this image, right? You define all this. Now what will ECS do? ECS sees this definition file and says, okay, you're saying W1, okay, let me go and find out in the registry, do I have W1? Oh, I see W1, right? Let me spin up five of them. Okay, what next? I need A1. Okay, I see the image, let me spin three of them. Okay, db1, let me spin two of them, right? So this is where you define, right? The image will have all your application code, and see, container registry is where you register the container, and task definition is where you define. You say, I want to run an application which is A1, and this application has these three containers, and I want to run these many of them. This is the whole thing that we talk about. So you have to point where your registry is, and based on that, you can do that. Arti will come to Fargate. Give me a minute. We'll come to Fargate. We've just seen one. We'll come to Fargate also. So this is ECS. So ECS is a way of running your containers, right? Uh, that's how you run your containers. Now, moving on. The second option that you have is EKS. What is EKS? EKS is Elastic Kubernetes Service. Now, what is Kubernetes? Kubernetes is an open source project, right? Which is also a container management service, right? So it's a container management service, but it's an open source. It's not, the earlier one was AWS proprietary. Now, Kubernetes is an open source, right? Now, if your organization wants to leverage Kubernetes, AWS also gives you managed Kubernetes, right? So what I mean by managed, manage means you have to install, operate, manage. You don't have to do anything. Everything is ready. You just say, hey, I want to use EKS. I create a cluster and I just run my containers, right? Now if you look at Kubernetes, Kubernetes has something called as control plane, right? This is basically the heart of Kubernetes cluster, right? This manages the whole Kubernetes. This will manage everything that's running under Kubernetes, right? So now what AWS does in EKS, is this control plane is managed by AWS. So you don't have to worry about the manageability, scalability of the containers, right? Or the control plane. That's all taken care by EKS. You just say, hey, I need a 3 node EKS, and this is my application definition, run this, right? EKS will run all that. Now, what is the benefit that you get here? This is an open source, right? So tomorrow, if you are not tied to AWS, tomorrow, if your organization says, hey, I have a multi-cloud philosophy, right? I want to build hybrid cloud architecture, right? Which means I want to use AWS and Azure and GCP, all three of them, right? Now, if you use ECS, then you are hard binded to AWS because that's an AWS proprietary solution. If you're using EKS, then it's Kubernetes, right? It's an open source. Now, all the cloud providers gives you Kubernetes solution. So today you're running here. You can run another container on Google Cloud, another container on Azure, right? You can have a hybrid environment and you can run across, right? You can easily move and move across. So it gives you that flexibility. Second, Kubernetes ecosystem is very vast and very powerful. There are a lot of products and projects that are going on Kubernetes. So Kubernetes is today one of the de facto standard for running a container orchestration platform. So you get all the support, you get all the latest that's happening, all the additional things that you need on the top of running your containers, all that is available in the Kubernetes ecosystem. So that's also a plus point, right? So that's where Kubernetes come into picture. Moving on, right? So we understood this part, right? So container registry, we understood this is where you store, manage, and deploy your container images, right? And then anyone can search and figure out which is the images, and they can run the images, right? Now, from a Fargate perspective, right? So now when you run, when you run your containers, there are two ways that you can run. One, you say, hey, I want to do everything on EC2, right? What is EC2? EC2 is basically the server, right? This is the virtual machine. So you run on virtual machines, right? And on the virtual machine, you run your Kubernetes, right? That's or ECS. That's option one. Option two, you go and say, hey, I want to use Fargate. What is Fargate? Fargate is a serverless container philosophy. What does it mean by this? So let me explain you. So when you use, let's say, ECS or EKS, right? I hope everyone understood the difference between ECS and EKS, right? So this is AWS proprietary, this is open source, right? Now, where does it run, right? So it runs on EC2 servers. So you create a 3 node cluster, right? Again, I'm just taking an example. Say you took a 3 node cluster. What is the 3 node? These are EC2 servers, right? So S1, S2, S3, C3 servers, and you are running your Kubernetes, right? And Kubernetes allows you to run your containers, right? This is your EKS. So from a compute perspective, you're running EC2 servers, right? Tomorrow, if you need more capacity, right, you would add one more EC2 server in the fleet, right? So that's what EKS or ECS runs. Now, if you want to say, hey, I don't care about all this, I cannot do all this management. I don't want to do the capacity planning of how many servers, what and all. You just give me, I have a Docker image, run the Docker image. I don't care how you run. I am not going to do management of this EC2 servers and all, right? That's where Fargate comes into picture. So Fargate is a serverless. You don't worry about it. You just say, hey, I want to run a container and I need one CPU and one GB memory. That's it. It will run it on its fleet of servers. Fargate internally under the hood would have fleet of servers where it will run, right? Your container will run. Now you don't care about what is the EC2 server, how big should I take, how many should I take. You just pay for what you use. So you are using one CPU, 1 GB, you pay for this. You don't care about the underline. In this, you have to worry about the underline, right? That the EC2 servers. You have to make sure that you have 3 EC2 servers and you're running 100 containers on the top of it. Here, you say, so here your payment is per node that you run, right? So let's say each, so you're running a three node cluster. right? So let's say each node, let's say it's $10 per hour. I'm just taking some number, guys, just to do a calculation. So 3 node means $30, right? And in 3 nodes, let's say you can run 30 containers. Again, I'm just taking numbers, don't quote me. This is just an example, right? You can run 30 containers. Now, if you want to run 31 container, right, you cannot run because now the capacity is full. You have to run one more node, right? So you have to go to 4 node. So your cost will be $40, right? But here, let's say, so if you're running 30 containers and $10, uh, each container cost is roughly $1, right? Now here, you don't worry about what is the underlying node and all. You say how many containers? I want to run 31 containers, right? And Fargate might come and say, okay, running one container would cost you $1, $1.1. So $31 containers would run you $31, $32, whatever the math comes in, right? $32 or $33, right? So you are running only for number of containers you run. You don't pay for the underlying host, right? So that's the major difference. Rest all remains the same, right? So Fargate is a serverless offering. You don't worry about the underlying hardware. You don't worry about the EC2 servers, how many of them, what capacity. I am now full. I should add one more, delete one more. All that is taken care under the hood. You don't have to worry about it. You say, hey, I want to run 2 containers, and this is my image. That's it. So that's the major difference between EKS, ECS versus Fargate. So that's Fargate, right? No need to provision or manage servers. Pay only for the resources that you use, right? You don't have to provision your EC2 servers, and it improves your security posture because now you don't have to patch the underlying hardware. You don't have to patch the servers. You don't have to worry about all this. This is all taken under the hood. You just say, hey, run 10 containers for me, right? So what are the major advantages of running containers on AWS? The major container, the first important thing is security, right? Because now you are running closely controlled, so you can tie up with a lot of security tools that AWS gives, and you have better control over the security posture, right? Because you're not running an OS, so OS is underlying managed, so you can control your security posture. It is more reliable because now you have better flexibility. You are not worried about the whole OS. You're running a very small, tiny thing, right? So that becomes more reliable because now you can run across multiple hosts, and your Kubernetes or your ECS will ensure that if one host dies, it will take care into another host, right? So the reliability factor is taken care by the container orchestration layer, and you have multiple choices, right? Because now you're not tied up to one thing. You can do multiple things across. And last but not the least, it is deeply integrated with other AWS services. As we were talking about, if you need other security tools, monitoring tools, and other application services like SES, SQS, SNS, all the other services that you want to integrate, you can easily integrate with it. So this is tightly integrated with the complete AWS ecosystem. So you can work across multiple different services with your containers, right? So think of it like you want to send email from your application, right? So you are Flipkart, right? And then whenever someone does a purchase, you send a mail, thank you for purchasing with us, right? And then your shipment would come soon, right? That email you want to send. So what you can do, you can build a container, you can build your application, run it on a container, and integrate that container, your application with SES. So what is SES? SES is a simple email service. So that helps you to send emails. That's a different service, but it's tightly integrated. You can closely work because both are AWS services. Right? So what are the different use cases that you have? Why should you use containers, and where are you going to use containers? So one of the use cases are where you want to build your microservices. What are microservices? Microservices are so this is basically a concept of domain driven design, DDD, right? So basically when you want to break applications, so think again, going back to our shopping app example, right? So if you're building, let's say, uh, Amazon shopping, right? Amazon.in, right? If you're building Amazon.in, right? So Amazon.in has multiple domains, right? So it has a inventory management system, it has a shopping application, it has a news application, it has recommendation system, and shipping tracking, inventory management, multiple modules it has, right? Now, one option that you have, put everything, build one big application, right? Everything is inside this. So it becomes very difficult to scale, very difficult to manage, upgrade, and many challenges. What is the other option? You build microservices. What is microservices? These are small services which does one job very good, right? So in your one application, which is Amazon.in, you might have one application which takes care of payments, one application which takes care of recommendation, one application which takes care of shipping. Now all this comes together and becomes one big application. So these are multiple microservices which works together. So now when you want to make microservices, you can leverage containers, right? Because each containers can run on different microservices and you can run more of them, right? So that's one use case. When you're building microservices, you can run those microservices on containers. Second use case is if you have batch processing. So if you have some huge batch processing that you want to run, and you want to trigger on a specific time, right? So think of it like Netflix, right? So what happens in Netflix? In Netflix, whenever they produce a video, right? So that they've shot a new video now, or a series. This series will be converted into 1,000+ different formats. So Netflix does this, right? This is a true thing, right? So Netflix converts it into multiple different formats, right? Because there are so many different devices that it support. You can run on your mobile phone, on your tablet, on your TV, on your laptop, desktop, right? So many different formats, different resolution, right? Different bandwidth needs. So all these, what they do, they take this one file, one video image, and they batch process. They convert it into multiple different formats, 1,000+ formats that they convert. And this is a batch process, right? So this batch processes can run on containers. That's a second use case that you can think of. Third use case, if you have machine learning. So if you're doing machine learning, you can again leverage containers to do so, right? Now moving on, you can also build hybrid applications. What is hybrid application? As we discussed, if you have applications running across multiple environments, means AWS, Azure, GCP, or in your data center versus cloud, you can leverage containers. You can seamlessly move across. You can move from one environment to another, and you can seamlessly execute your applications. It also helps you to migrate to cloud, right? Because now if you have a container running in your data center, or your own on premises, it is very easy to migrate, right? You just have to run those containers on cloud. You have all the infrastructure. So think of it, the Kubernetes that we were talking about. If you're running Kubernetes on your data center, right? Now you want to migrate it to cloud. You run Kubernetes and just run the container. The images are there. You just copy the image and run, and you say I want 10 definition of that. So life is easy. So whenever you're doing application migrations to cloud, containers becomes a very important things. So today we have seen many customers, what they do, they containerize their application in the data center and then they migrate, right? So many customers are taking the route where they modernize and migrate, or vice versa, migrate and modernize. But typically now customers are seeing value for modernizing and migrating, so they can move to containers and then they can migrate to any cloud of their choice. So that's what we had, right? So I hope this session was useful. You have got a little glimpse of it. Thank you guys.